find the area of irregular shapes. We're going to be finding the area of irregular shapes. Now, in order to find the area of irregular shapes, one skill that we're going to have to be able to do is we're going to have to analyze figures that are given to us, the dimensions that are given to us, and figure out what pieces we may need and what pieces we may be missing, and figure out how to get those particular pieces. So, looking at this problem is not a rectangle, it is not a triangle, and it is not a circle, which means at this point we have not discussed a formula in order to find the area of this particular shape. Therefore, the way that we're going to go through problems like this is we're going to break them down into shapes that we do know how to find the area of. So, for instance, I could take this shape and I could break it into 2 rectangles, and all I would have to do is find the area of each rectangle and add them together. Now, when I look at this in particular, if I want to find the area of this second rectangle down here, call it area 2, I would have to know the dimensions of length, which I've labeled as y, and width, which I've labeled as x. But those are not immediately given to us. However, there is enough information given to us in the problem to help determine what those values are. Let's start with x. This is a critical thinking skill that you must use. So right now, if you are not trying to figure out the value of x all on your own, using geometric principles, then you are not going to be successful in learning today. This is not a skill where I can say, hey, this is what you do every time. This is a skill where you have to practice using critical thinking skills and kind of putting together ideas. So right now, I'm going to give everybody 25 seconds to look at this figure and see if they cannot determine some way to figure out the value of x, the length of that side, based on the information that is given to you. All right, what is the value of an x? And be prepared to explain to me how you got it. William.
I think it's 22 because you know how it's a square and then it has 7 inches on top?
Yep. So I kind of hear him saying, it's kind of like if I just keep extending these lines, I know that this part of the line is the same thing as this 7 up here. Okay? But that's not 22. You said 22. Where'd the rest of that come from?
15.
So the 15, it's again kind of like extending this line down. We see that this is the opposite of that rectangle, which would be 15. So if we see the entire length of this particular line here, all the way from here to here, we pass 15 and then 7 more. That means that that x must be a total of 22. So x is equal to 22. Now, is there anybody who's confused about where that 22 came from? Because if we are confused about where that 22 came from, then we are not setting ourselves up for success for today. Michael, you're confused. Okay? So again, we're looking at the entire length here. We can break that entire length up into kind of 2 parts, using this kind of as a dividing line. And on the right side of that dividing line is this chunk here, which we see as 7. On the left side of that dividing line, we have this piece, which we can see the length is 15. So if one part of it is 15, the other part of it is 7, that means the total is 22. Michael. Next, we want to talk about y. Y is the trickier of the two. I'm going to give you an extra 20 seconds to figure out something about y. What is the value of y?
5.
Ricardo? 7.5. And why would you say 7.5?
Because it's the same thing if, like,
The 15, if you cut it in half, it's like the same size as it.
So that's guessing that this line cuts it directly in half. That's making an assumption. And one thing that you're going to learn when you get into geometry in high school is that your geometry high school and teacher is going to say, no matter what you say, they're going to say these two words. Prove it. Prove to me that that splits that directly in half. So there is no way to prove based on the information given here that this line cuts this directly in half. In fact, there is actually proof that it does not. Andrea. All right. So she is saying, she's cutting it up here. And she's saying, look, if I have this 15, I know this part is 9, which means this part is 6. Since it's the opposite side of a rectangle, that must also be 6.
How'd you get 6?
That's fine. For most classes, I've had to explain this twice. So everybody's on board. And I want everybody to be on board. So I'm looking at this. Another way to kind of think about it, Michael, is to say, all right, I have this entire shape is 15. This part of it is 9, leaving me 6 left over. Okay? All right. So let's look at the next one. Now the next one, if I wanted to break this particular shape up into parts I knew how to find the area of, I would probably be breaking it up into 3 rectangles. Now, in order to find the area of all 3 of those rectangles, I would need to know the value of x and the value of y. So, let's start with y, because y is the easy one. Take 10 seconds. What is the value of y? And be prepared to explain yourself. Armando. Y is 8. Why? Yeah, so he's saying that we basically can extend this line out, and this basically makes one big rectangle, which would mean that opposite sides of the rectangle are the same. So y is equal to 8. Okay? What about x? What about x? Take 25 seconds because this one's more complicated than any other one we've done today. Take 25 seconds to determine value of x. Mr. Matlock. 12. He says 12. How did you get 12? Guys, put your hands down. He's answering a question. 8 plus 4 is 12. Okay? Any other ideas? Jacqueline. You say it's 4. Okay, Jacqueline, you say 8. How did you get 8? Okay, so what I hear her thinking through is this entire chunk up here is 16. Yes. And she knows this part is 4, and this part is 4. In order to make it work so it all adds up to 16, what would have to be in the middle would be 8. Now let's look at the last one. Looking at the last one. Start with x. X is the easy one. I'll give you 5 seconds. Damian. That's you, Damian.
Oh, me, okay.
Damian.
X is?
I got 6.
6. How'd you get that?
Plus it's parallel from 6 same as from the last side.
Right, so it's the opposite side of this rectangle which means it's the same. Y, this is the trickier one. I'll give you 15 seconds.
Yeah.
Joseph.
So, what I did was, if it was like a full rectangle,
Yep.
I did, it would be parallel with 13, but it's not, and so I did 13 subtract 7, and I got 6.
So he's saying this breaks it apart. This opposite part would be 7, leaving the remainder would be 6. So we actually end up with both of those dimensions being 6. All right, so this is just the piece that gets us started. Questions about it? Ricardo.
Another way you can think about it is like you could turn the triangle and pop it up, like draw like a square.
Like this.
So again, that sounds like that may be making the assumption that that would make a square. You cannot make assumptions in geometry. Do not make assumptions in geometry. You cannot assume thing. So now we're going to get into the real work for today. I have this particular shape right here, and I want to find out the area of this particular shape. However, in this particular shape, it is not a rectangle, it is not a square, it is not a triangle, and it is not a circle. Those are the things that we know how to find the area of. So, what can I do with this particular shape in order to make it something I can find the area of? Mr. Posey.
Make it into 2 shapes, you know how to find the area.
All right, what 2 shapes would you like to make it into? Show me on your paper so I can replicate on the board. Okay, Mr. Posey is cutting this shape like this. So we have a rectangle and a triangle. So we know the area for a rectangle is length times width, so we will have to find dimensions of length and width for it. The second shape being a triangle, we know is 1/2 base times height, so we know that we'll have to find the base and the height of that triangle. Now, starting with the rectangle. The rectangle is super easy, really easy to find the dimensions there. What are the length and width of this rectangle? Oscar.
$10 and $25.
10 and 25. So this rectangle runs this entire length here. This is what's 25. No, 25 is way more than what we actually need. Ricardo. 10 and 12. So the height is 10 and the length is 12. So we have length is 10, width is 12. Oscar, do you understand why this 25 does not work for the length of our rectangle? Okay, so this 25 runs all the way to here. Our rectangle only goes to here. So that 25 is way more than the length of our rectangle. All right, looking at our triangle. Now our triangle, we don't have any of our dimensions on this triangle labeled, so we're going to have to figure them out. Okay, so I need to find the dimensions of this triangle. Somebody help me out. Renee, let's find the dimensions of this triangle here. So we're going to call this area 2. We need to find the dimensions of that triangle, base and height.
Okay, so you have to subtract 12 and 25.
So she's saying this entire thing is 25. If I know this piece is 12, then that means this base must be 13. Are we crystal clear as to why that is?
Yes.
Anybody confused about that? And the height, Brene, of our triangle. It's 10 because that's the opposite side of this rectangle right here. So we have base and height 10 and 13. So now all I need to do is find the area of my two shapes. The area of the rectangle, area 1, is length times width. We said the length was 10 and the width was 12, which means the area of the rectangle is 120 square centimeters, or centimeters squared. The area of the second shape we said was a triangle. So the area of the second shape, we're going to be using the equation 1/2 base times height. We said the base was 13 and the height was 10, which means we're looking for half of 130. Half of 130 is 65. So what's the area of the shape, 120 or 65?
Either.
Trick question. Good. What do I need to do to find the area of this shape, Oscar?
Multiply them?
I need to add these two areas together.
Oh.
Because I got one area, I got another area, and then we put them together. It makes sense. So our total area total, is equal to A1 plus A2, which is 120 plus 65, which is 185 square centimeters. Questions about that one? Oscar.
After you added, how come it's still squared? Yeah.
Because we had centimeter squared plus centimeter squared. That's like having 3x plus 4x is 6x. That's only if we multiply. Centimeter, that'd be like 4x times 2x would be 8x squared. But if we add, remember, coefficients stay the same. Or exponents stay the same. So looking at the next one, we have another shape that we do not have a formula for. It's not a rectangle. It is not a triangle. What am I going to do with this particular shape if I'm going to be able to find the area of this shape? Yang.
Cut it into two shapes. Yeah.
Show me how on your paper so I can replicate for everybody else. All right, Yang has suggested that we cut it like this, making two rectangles. Is there another way I could cut this and it'd still be fine?
Yeah.
Yeah, absolutely. I could have cut it across like this. It doesn't really matter. Either way, you're going to get the same answer. One way will just require different dimension finding than the other. So I've got area of my first rectangle and area of my second rectangle. Those are going to give me my total area. Shape 1 is a rectangle. Shape 2 is a rectangle. Length times width. Oops. I need to find my length and width. I need to find my length and my width, because both of these have areas of length times width. So looking at shape 1, this is going to be the one that I'm going to just really quickly shade here in green. Looking here at shape 1, what are the length and width of this rectangle? Oscar.
6 and 18.
6 and 18. These are obvious. They are given to us. Right as we come along the edge, we see those two edges are labeled. Length and width are 18 and 6. Now, for our second rectangle, things are not quite so given to us. So this one's going to be a little bit more complicated. I need to find the length and the width of this second one. So, somebody help me out. Sadie. Sadie, help me out here. Let's start with this one. This length here.
8 plus 6 makes 14.
Perfect. So she's saying the 8 accounts for, if I just come across over here, the 8 counts for this part, and the 6 would account for this part, which means this would be a total of 14. So the length is 14. Now, what about the width? Talking about from here to here. From here to here. So Jacqueline, let's figure it out. Why? Okay, so Jacqueline recognizes that this part would be 18. The entire thing is 27. So that means this part that we're looking for would be 9. So we've got 2 areas defined here. Area 1 is equal to length times width. The length and width we said were 18 and 6. Be 3654, 108 square inches. And area 2 is equal to length times width, which is 14 times 9. Should be 63, 126. And so if we wanted the total area, we would be adding these two together, A1 plus A2. That would be 108, 108 plus 126 would tell us that our total area was 234 inches squared. Negative space is an area that has been taken away from a larger space. So in this particular problem, our negative space would be this here. This middle part has been taken away from a much larger original shape, which was a much larger rectangle. The way I think about this problem is I think about this as a giant tray of brownies. I had a giant tray of brownies, and then Ricardo came along and scooped out a big giant brownie out of the middle of my pan. I'm not happy about it. I want to know how much is left. So the way I figure that out is I say, okay, well, I started with this giant, large, red rectangle. And I want to say to myself, well, how much did I start out with? What is the length and width of my entire brownie pan? My entire red shaded area? What are the length and width of my entire brownie tray? Mr. Ross. 25 and, 12. Sorry, I didn't hear you. So I can find out the area that I started with. My area 1 is equal to length times width. is 25 times 12. And so I started with 300 square centimeters of brownie. Now I can also go through and thinking about this blue part that I've shaded here. That's my negative space. That's the part that Ricardo came and took away from my brownie tray. I want to find out how much he took away. So that's a rectangle that has a length and a width. What is the length and width of what Ricardo took away? Oscar, what is the length and width of what he took away?
10 and 12.
Yeah, he took out a 12 by 10 piece. So the area of what he took away, I'm just going to call this A sub n, A for the n being negative space. And this says that this negative space he took away was length times width is 10 times 12. So he took away 120 square centimeters of brownie. Not a happy camper about this. So the question is, if I have the shaded region left, how many square centimeters of brownie do I have left? What do I need to do to figure that out? Andrea, subtract. So to get the area of my shaded region, I take the area I started with, area 1, and subtract the negative space. So that's 300 minus 120 is going to give me 180 square centimeters. So that's the area of the shaded region.
Wait, so we don't do the area formula? We didn't write it.
So let's look at this next one. So I was very generous in this particular problem in giving this to you the way I did, because it's quite possible this could have been given to you and may be given to you on the CST looking much more like this. And you would be asked to find the area of the shaded region. And what you would have to recognize is that this is really just a rectangle in which somebody cut off the corner. So I gave that to you. I showed you that. So I had a large brownie pan. What was the large shape of my large brownie pan that I started with? Yang.
25 centimeters by 10 centimeters.
It is a rectangle that is 25 by 10. Which means that I need length times width. So I started with area 1 is length times width, 25 times 10. Area 1 was 250 square centimeters. So I started with this nice, beautiful pan of brownies that was 250 square centimeters. But Ricardo came along again. I'm going to call him the brownie monster. And he came and lopped off this corner, which just so happens to be what shape?
Triangle.
Triangle. And so I need a base and height for that triangle. What are the base and height of that triangle? 3 and 3.
Good job.
So the area of the negative space that he took away from me is 1/2 base times height, or 1/2 3 times 3 is 1/2 of 9. Half of 9
4.5
is 4.5. So to find out what I have left, I take my A1, I subtract my negative space. That's 250 minus 4.5 would give me 245.5 square centimeters. So the area of my shaded region is the same thing as what I originally had, minus the area of the negative space.
I get it.